Imagine a perfectly clear night, when the city has faded far behind you, when no lights wash out the sky, and the air is clean enough for the stars to appear in their full clarity. Above, a pale band of light stretches like a silver mist across the heavens, running from one horizon to the other. That soft glow isn't a cloud, nor a fleeting weathered shimmer. It's the view from inside the very galaxy we live in, the one humans have named the Milky Way. To the naked eye, that luminous streak seems so fragile, like someone brushed a faint line of chalk across a velvet black canvas. Yet behind that gentleness lies a structure so vast, it surpasses anything we're used to imagining. Every speck, every soft patch of light blending into the Milky Way is actually the combined glow of hundreds of billions of stars. Each star its own sun, with its own heat, its own mass, and its own story. If the night sky could be magnified millions of times, that single ribbon of light would break apart into an ocean of individual stars, so dense it would seem as though there were no empty space left between them. The Milky Way takes the shape of an enormous, slightly twisted disk, with curved spiral arms that sweep around a bright, compact core. This cosmic disk is roughly 100,000 light-years wide, meaning that if a beam of light started at one edge, it would take 100,000 years to reach the other. Within this disk are not only stars, but enormous clouds of gas, thick curtains of dust that swallow starlight, clusters of ancient stars, nurseries of young ones, the scattered remnants of supernovae, and even dark matter, an invisible presence our eyes and optical telescopes cannot detect. Somewhere in that vast sea of stars, our solar system is only a tiny point, tucked away in a relatively quiet region near the galactic outskirts. The Sun is an ordinary star, not too large, not too small, not exceptionally hot or cold. Earth is just a modest planet circling it at just the right distance for liquid water to endure, for an atmosphere to cling to its surface, for simple chemicals to slowly assemble themselves into complex living structures, and eventually into brains capable of lifting their gaze toward the sky. When we look at the Milky Way arching overhead, we're actually looking along the galactic disk itself, where stars align in such a dense direction that the sky appears richer and brighter. Long ago, civilizations all over the world looked up at that band of light and spun myths around it, imagining celestial pathways, rivers of radiance, or trails left behind by gods. They didn't yet know the concept of galaxies, nor understand numbers like 100 billion stars or 100,000 light years. Yet they could still sense the mystery in the sight above them. Over time, as science grew, humanity learned that the Milky Way is a galaxy, that the Sun is just one among countless stars within it, and that beyond it lies an unending multitude of other galaxies, each filled with billions of stars of their own. That understanding doesn't make us small in a discouraging way. It expands the frame of where we belong. Instead of standing at the center of a tiny universe, we become one small part of something unimaginably larger, yet still capable of observing it, measuring it, and telling its story. Lying beneath the night sky, thinking about this, one might feel a strange peace. We are not alone, but resting inside a vast, ordered system with laws, history, and a future stretching across billions of years. Even without knowing every scientific detail, simply understanding that the soft glow above is the combined radiance of hundreds of billions of suns is enough to transform how we feel about the sky. Instead of seeing isolated points of light, we can imagine a slow-turning stellar disk in the darkness, within which Earth drifts quietly, carried along by the Sun as it orbits the center of the galaxy. One such orbit takes about 230 million years, far longer than the entire history of humanity. And yet, that journey is happening right now, moment by gentle moment. On a quiet night, imagining yourself lying on the surface of a small planet, circling an ordinary star, inside a slender arm of the Milky Way, the noise of daily life starts to soften. Worries, schedules, deadlines, headlines, they all drift downward and away, making room for a simpler awareness. You are living within a vast universe, breathing in rhythm with the slow, ancient rotation of the galaxy, listening to the story of stars told through their light. The Milky Way stretches across the sky, familiar yet endlessly mysterious. Even with all we know about its structure, its star count, its distances and timelines, there is still a part of it that remains quietly magical. And that lingering sense of wonder gives us something precious. Every time we look up, or even just imagine that misty band, we have a chance to settle ourselves, to remember that we are small but not lost, sheltered within a cosmic home far more enduring than the fleeting worries of a single day on Earth. In that stillness, even the driest numbers soften into something gentle. Beneath the wide Milky Way, stretched across the sky like a silver ribbon, the light of hundreds of billions of stars appears as a gentle reminder of the cosmic home we all share. And as that sense of vastness lingers in the mind, our thoughts naturally drift towards something much smaller yet deeply familiar. The place where every memory and every human story begins. From that galactic glow, the quiet journey of awareness returns to its closest point of origin, the solar system. Among the countless star systems scattered throughout the Milky Way, the solar system is only one of hundreds of billions like it. Yet it is the foundation for all our observations, reflections, and understanding. The sun stands in that wide expanse like a steadfast lantern, radiating the energy that keeps planets, moons, and countless smaller bodies in their steady orbits. Its light comes from continuous nuclear fusion in its core, where hydrogen is transformed into helium, releasing enough energy to illuminate space for billions of years. Seen from afar, the solar system would be just a small glow amid a crowded sea of stars. But for Earth, it is the source of life, the center of every natural rhythm and cycle. Earth is only one of 8 planets orbiting the Sun, yet it holds something special, a distance perfect for liquid water to persist, gravity strong enough to hold an atmosphere, and a geological structure capable of supporting complex cycles that sustain life. Among the countless planets humanity has observed in the universe, very few offer comparable conditions. Earth may appear like a tiny blue speck suspended in space, but it is a speck that contains the entire history and memory of humankind. Seen from the outside, Earth shines only as a faint glimmer reflecting sunlight. Yet that fragility is precisely what makes it precious. Closest to the Sun is Mercury, the smallest of the 8 planets. Mercury races around the Sun so quickly that it completes one orbit in only 88 days. Its cratered surface resembles the Moon's, while its temperatures swing dramatically, from blistering heat during the day to deep cold at night. Lacking a thick atmosphere to balance these extremes, Mercury offers no place for liquid water or life as we know it. Yet its existence reveals the remarkable diversity among planetary bodies, a small but important piece in the solar system's grand mosaic. Not far beyond lies Venus, a planet nearly Earth's size but utterly different in nature. Venus is wrapped in a dense carbon dioxide atmosphere, creating an intense greenhouse effect that makes its surface hotter than Mercury's, despite being farther from the Sun. Thick clouds of sulfuric acid blanket the planet, allowing little sunlight to pass through. Venus stands as a stark contrast to Earth, a world of heat, pressure, and blazing confinement. A vivid reminder of how fragile the conditions for life truly are. Leaving Venus behind, Earth emerges as a gentle counterpoint. With oceans covering most of its surface, a temperate atmosphere, and a rich web of ecosystems, it is one of the rare known planets in the universe that hosts life. Earth's color palette ranges from the deep blues of its seas to the warm browns of its deserts, the whites of clouds and ice, all blending softly beneath the sun's illumination. This delicate balance has allowed life to evolve over billions of years, from single-celled organisms into the vast diversity we know today. A little farther out lies Mars, the shimmering red planet. Its surface is coated in iron-rich dust that gives it its unmistakable color. Many features on Mars hint at ancient rivers that once carved through its terrain. Dry riverbeds, cracked channels, the outlines of old lake basins. Today, its atmosphere is thin, but ice persists at the poles and beneath the surface. Mars reveals a world that feels oddly familiar. Mountains, valleys, deserts, and enormous dust storms sweeping across its plains. Though no evidence of life has yet been found, Mars remains a promising frontier for future exploration. Journeying outward, the giant planets begin to appear. Jupiter, the largest of them all, contains more than 300 times Earth's mass and could fit over 1,000 Earths inside. Jupiter is a swirling world of gas, its atmosphere striped with bands of color and dominated by the Great Red Spot, a storm that has raged for centuries. Orbiting this colossal planet are dozens of moons, including Europa, whose icy shell may hide a vast liquid ocean beneath, stirring hope for possible life far from the Sun. Beside Jupiter is Saturn, adorned with its breathtaking rings. These rings consist of billions of pieces of ice and rock, some as small as grains of dust, others the size of mountains. Though they are astonishingly thin, Saturn's rings create one of the most majestic sights in the solar system. Saturn also hosts fascinating moons, like Titan with its thick atmosphere and methane seas, and Enceladus, whose icy geysers hint at geological activity beneath its frozen crust. Farther still are Uranus and Neptune, the two ice giants. Their blue hues come from methane, which absorbs red light and reflects blue. Uranus rotates on its side, almost horizontally, giving it seasons that last for decades. Neptune is known for the strongest winds in the solar system, reaching thousands of kilometers per hour. Both worlds add unique colors and textures to the solar system's rich diversity. Beyond the planets lie regions filled with countless smaller bodies, asteroids, comets, meteoroids, all traveling along their own paths, sometimes sweeping close to the inner system before drifting back to distant realms. Together, they form a vast yet orderly system, governed by gravity and motion shaped over billions of years. Although the solar system occupies only a tiny corner of the Milky Way, it is here that every human observation has been made. Looking back, we see ourselves living in a cosmic family, sun at the center, planets and moons circling like members with their own personalities and stories. Together, they form a balanced system of energy, gravity, and motion. Amid the immensity of the universe, understanding the solar system not only reveals Earth's modest place, but also awakens a special feeling. Though small, our blue planet is home to life, home to beings capable of looking outward, asking questions about origins, futures, and the meaning of existence. And as the imagination drifts beyond this familiar star system, our awareness gently opens into a wider space where distant points of light begin to appear on the map of our cosmic journey. From the peaceful feeling of looking back at the solar system as a family circling its warm sun, the mind naturally drifts outward toward the place where wide orbits begin to cross paths in the depths of space. And when awareness touches the boundary between the familiar and the untouched, the journey gently shifts, guiding the imagination into a quiet voyage through the planets. In this imagined journey, we depart from Earth's orbit, where the blue planet has turned steadily around the Sun for more than 4 billion years. As the distance grows, the clouds, oceans, and continents slowly blend into a single blue-white sphere glowing softly in the cosmic dark. Behind it, the Sun shines like a steadfast beacon, radiating the light that nurtures that entire miniature system. From afar, the whole history of humanity, every story, every civilization, seems to fold into that lone, shimmering dot. Yet that very smallness makes the journey feel even larger, as though the sky ahead were quietly opening, waiting to be explored. The first destination is Mars, the quiet, glowing red planet. From a distance, its rosy tint drifts like a soft ember in the dark, hinting at a world where water once shaped the land. Deep valleys, ancient riverbeds, and layers of silent sediments tell of a past that may have been far wetter than today. Dust on Mars reddens both its surface and its thin atmosphere. Though it no longer has oceans or flowing rivers, traces of water remain in polar ice and frozen reservoirs beneath the ground. Looking at Mars is like turning the page of an old, weathered book about Earth itself, full of mysteries still waiting to be understood. As Mars recedes behind us, a vast stretch of empty space opens before the next bright presence: Jupiter, the giant of the solar system. At first glance, Jupiter appears as swirls of colorful bands twisting around one another, carved by immense storms. The most famous being the Great Red Spot, a tempest large enough to swallow Earth whole. Winds on Jupiter are so powerful that the cloud layers stretch into long streaks circling the planet. With no solid surface, Jupiter is a colossal sphere of gas, its temperature and pressure rising dramatically toward the center. Yet its true majesty is revealed in its many moons, some potentially hiding subsurface oceans beneath their icy shells, like Europa, whose smooth white crust may be concealing a deep ocean warmed by the planet's internal energy, possibly creating conditions suitable for life. Leaving Jupiter, another faint glow begins to sharpen, and as we approach, wide and delicate rings unfold like a natural work of art. Saturn. From afar, its rings look like a thin, bright plane encircling the planet, but up close, they are made of billions of icy fragments, each reflecting sunlight like drifting, glittering dust. Saturn's density is so low that, in theory, it could float in a massive ocean of water. Even so, its lightness does nothing to diminish its grandeur. Saturn's moons bring their own wonders, like Enceladus, where icy geysers erupt from the surface, hinting that beneath the frozen crust may lie heat and liquid water. As the journey continues outward, sunlight weakens and the darkness grows deeper. Uranus appears as a pale blue sphere drifting quietly through the void. Its most peculiar trait is its tilt. Its axis lies nearly sideways, as though the planet had been tipped over. Because of this, its seasons last for decades, each with its own subtle shading of light. The planet's cold, gaseous atmosphere contains high levels of methane, giving Uranus its soft blue color. Even farther out, Neptune emerges in a deep, darker blue, cold, distant, and mesmerizing. Though far from the sun, Neptune boasts the fastest winds in the solar system, with clouds racing at thousands of kilometers per hour, spiraling into enormous storms. Neptune's moon Triton adds another layer of intrigue, a frozen world with nitrogen geysers that send towering plumes of mist into the thin air. Triton's unusual retrograde orbit suggests it may once have been a large Kuiper belt object before Neptune captured it. Crossing Neptune's orbit, the solar system begins to expand in a different way. Ahead lies a realm where planets no longer serve as familiar landmarks, a region filled with scattered icy bodies, comets, and drifting asteroids traveling on long, eccentric paths, waiting for their moment to swing back toward the inner system. Here, sunlight is no stronger than the glow of a bright distant star, faint, yet still present. At this far edge, the silence deepens. Distances stretch so wide, the time and space seem to melt into a single, quiet expanse. This is where the solar system ends in the human sense, and where interstellar space begins. In this vast twilight, the mind can feel the shift, sensing that the journey is nearing an entirely new domain, one no longer held by the close embrace of planetary orbits, but the wide, open ocean of space between the stars, where new suns, new worlds, and new stories await their moment to be named. As we prepare to cross that boundary, the solar system behind us shrinks into a soft halo of light, a fading memory drifting into the dark. And as that glow merges with the surrounding night, the sense of cosmic vastness stretches once more, gently opening the way for the next chapter of the universe to begin. The echoes of the journey through the planets still ripple gently, like soft waves in a quiet lake. And as Neptune's blue silhouette fades into the distant dark, the mind naturally turns forward, toward the place where the boundary of the solar system waits. From that final orbit, the journey opens wider, carrying the imagination into a region more sparse, colder, and older than any place visited before. Beyond Neptune's path lies a vast expanse where sunlight has weakened into a dim, fragile glow, just enough to cast faint reflections on the drifting ice that wanders silently through the dark. This is the Kuiper Belt, a sprawling region filled with thousands of icy bodies, from fragments only a few hundred meters across to objects hundreds of kilometers wide. Pluto is one of them, a distant, frigid world with icy mountains and frozen plains of nitrogen, circling the sun like a quiet traveler of the shadows. The Kuiper Belt is thought to be a primordial archive of the solar system, a place where remnants from over 4 billion years ago are still preserved. Leaving the Kuiper Belt, space becomes quieter, wider, and deeper in shadow. This empty stretch leads toward one of the most mysterious structures ever envisioned by humans, the Oort cloud. The Oort cloud cannot be observed directly. Its existence is inferred from the paths of long-period comets, wanderers so distant that their return to the inner solar system may take tens of thousands of years. This cloud extends from around 2000 AU to hundreds of thousands of AU from the Sun. To imagine it, recall that 1 AU is the distance from Earth to the Sun, and 100,000 AU is nearly half the distance to the nearest star. The Oort cloud forms a massive, delicate shell around the solar system, thinly populated, yet so vast it defies simple intuition. It is believed that each icy fragment within the cloud carries a story from the solar system's earliest days. Some were flung outward by the gravitational pull of giant planets. Others were drawn into such enormous orbits that a single revolution may take millions of years. Even without direct observation, the idea of the Oort cloud evokes a quiet grandeur, like a pristine frontier where sunlight barely brushes the frozen surfaces of the most distant worlds. Here at the edge, the sun's gravitational influence begins to weaken. Objects in the Oort cloud no longer cling to the sun the way planets do. This is considered the true boundary of the solar system, the place where the sun's authority fades and interstellar space begins to speak. If a grain of icy dust drifts beyond this region, it will not return. It becomes a wanderer of the galaxy, belonging to no single star. No description of the solar system's outermost border feels complete without the story of the Voyager missions, the small yet resilient messengers of humanity. Voyager 1 and Voyager 2 were launched in the late 1970s, carrying golden records engraved with the sounds and images of Earth, a quiet greeting to any civilization that might encounter them in the distant future. Over more than 4 decades, these spacecraft traveled past the giant planets, capturing humanity's first close-up views of Jupiter, Saturn, Uranus, and Neptune. After finishing their missions in the inner system, the Voyagers pressed on toward the edge. When Voyager 1 passed about 120 AU from the Sun, its instruments detected a sudden change in the surrounding environment. The solar wind had weakened to the point where it could no longer overpower the pressure of interstellar space. That was the moment the spacecraft crossed the heliopause, the boundary of the Sun's protective bubble, and officially entered interstellar space. From that vantage, the Sun appeared merely as a particularly bright star, no longer the dominating center it once was. The moment Voyager crossed that threshold felt like someone stepping quietly out of their home and into a vast field without borders. Interstellar space is extremely cold, extremely thin, and profoundly still. It is made mostly of lone atoms, with the occasional dust grain drifting through the shadows. Yet this region remains part of the Milky Way, a silent connective tissue linking all star systems, like the pauses between notes in the galaxy's grand symphony. The scale of this region becomes clearer through one simple fact. Even light, the fastest thing humanity knows, would need almost a year to cross the width of the Oort cloud. For something as swift as light, a full year spent traversing only the solar system's outer shell hints at a realm far beyond ordinary comprehension. And when contemplating this, a gentle sense of floating takes shape, as though each thought drifts alongside ancient particles left from the solar system's birth. Out here, there is no noise, no swirling chaos like the regions near the giant planets. Instead, space unfolds in a deep and steady calm. That quiet is what makes the edge of the solar system so special. It is the birthplace of long-period comets returning inward after millions of years. It is the passage through which humanity's probes sail outward to become the first emissaries in interstellar space. And it is here, too, that the delicate boundary between the known and the unknown opens like a doorway leading into distant reaches of the Milky Way. Crossing that threshold, the solar system gradually shrinks into a soft point of light in the imagination, and from that moment on, the journey takes on a broader meaning. Not merely a tour of the sun's planets, but a voyage into the depths of the galaxy itself, where a wider universe waits to be explored with quiet wonder and awe. From the hazy boundary where the Oort cloud stretches into darkness, the solar system slowly shrinks into a quiet speck of light suspended in the endless void. And as awareness reaches the threshold where the sun's influence nearly dissolves, the journey gently turns a new page, into a chapter where interstellar space begins to unfold like a calm ocean untouched by human presence. Interstellar space, though it may sound like an empty expanse, is in truth a vast region filled with subtle, delicate features. It is not a perfect void, but a domain of gas and dust stretched thin between the stars. So thin that if those particles were gathered together, they would require a sphere hundreds of meters across just to contain a few molecules. Lone hydrogen atoms, tiny grains of carbon dust, faint radiation, and whispering magnetic fields drift quietly in the darkness, forming an environment cold but essential to the structure of the galaxy. This space is the quiet medium that connects star systems, the open room that allows them to circle the center of the Milky Way without colliding. As the journey moves deeper into this region, the sun's light dims until it glows no brighter than an average star in a night sky. It is no longer a dominating beacon, but a bright point only slightly larger than the others nearby. Surrounded by deep shadows, the feeling is like having traveled far from home, adrift in a sea of stars unlike anything familiar. Each star appears as a small, sharp glimmer scattered across the blackness, like crystals suspended in an endless void. What makes interstellar space striking is its profound quiet. There is no sound, no atmospheric stirring, no familiar winds or dust storms. Everything seems to rest. Every passing dust grain carries a sense of ancientness, perhaps older than the sun itself. Some grains may be remnants of stars that exploded hundreds of millions of years ago. Their material cast outward in supernova blasts, drifting through the galaxy until swept aside by the solar wind and carried even farther from the sun. Nowhere in the solar system carries a history as long as this, an unwritten record made of dust, light, and near absolute silence. Crossing the heliopause, the final protective boundary shaped by the solar wind, the first change one senses is the character of the environment. The number of charged particles and cosmic rays rises slightly. Beyond this point, there is no solar wind rushing outward. Instead, there is the galaxy's wind, streams of energetic particles drifting in from ancient supernovae or from star-forming regions in the spiral arms. Though faint, these particles are entirely different from those in the sun's domain, like stepping from a warm room into a vast, empty plain under a winter night sky. Interstellar space is relatively stable, yet it has structure. Its density varies from place to place, thicker near clusters of young stars, thinner around supernova remnants. But these changes unfold slowly over enormous distances. Even a spacecraft traveling at humanity's fastest speeds would need tens of thousands of years to cross only a small portion of this region. This slowness makes time feel stretched, almost softened, within the stillness of the dark. The two Voyager spacecraft were the first human-made objects to touch this interstellar realm. Signals sent from Earth take many hours to reach them, and their returning messages grow fainter with each passing year. Yet despite the immense distance, Voyager continues to send back priceless data, recording particle densities, tracing magnetic field shifts, listening to subtle ripples in the surrounding plasma. Each faint signal feels like a whisper from the universe, describing a place where no human has ever stood. Imagining oneself drifting through interstellar space evokes a solitude that is peaceful rather than frightening. This quiet is not an absence of meaning, but a kind of opening, where thoughts become slower, lighter, and more free. There are no crowded planets, no scorching sunlight, no heavy gravitational pulls. Everything seems to stretch outward, offering a sense of spaciousness infused with the presence of the cosmos. Looking around, each star becomes a possible solar system of its own, each small point of light a place that may host dozens or hundreds of orbiting worlds. In the soft darkness, the possibility of undiscovered worlds appears, places not yet known, holding secrets that science is only beginning to uncover. As the path continues deeper into the void, it begins to tilt in the direction of the nearest star system beyond the Sun, Alpha Centauri. The distance, more than 4 light-years, seems deceptively short on a galactic map, but in reality, it is vast enough that current spacecraft would need tens of thousands of years to cross it. Yet within the quiet flow of the story, the journey becomes gentle, a slow drift toward the Sun's first stellar neighbor in the Milky Way. Interstellar space is not an ending, but an entryway into an even larger realm of the universe. As the journey turns toward other stars, the enormity of the galaxy becomes clearer. Every point of light in the sky is a distant sun, and each sun could be the beginning of a new story. And in that soft, expansive darkness, the Milky Way begins to appear not just as a backdrop, but as a vast landscape welcoming the first tentative steps of exploration. From the quiet interstellar expanse stretching out like an endless black ocean, awareness slowly drifts toward the nearby points of light shimmering gently in the dark. And as the sun's glow fades into the distance like a memory long past, the journey, once feeling as if it were floating without direction, begins to narrow into a single destination: the star system closest to us, Alpha Centauri. On the map of the Milky Way, Alpha Centauri lies just a little more than 4 light-years from the solar system, a distance that feels both near and impossibly far. Near, because on a galactic scale, 4 light-years are barely more than a single step. Far, because with the speeds of current spacecraft, humanity would need tens of thousands of years to reach it. Yet in the quiet journey of imagination, that distance softens into a gentle pathway, guiding our awareness toward the first neighboring star system humanity has always longed to understand. Alpha Centauri is not a solitary star. It is a triple star system, complex, yet beautifully balanced. 2 of its stars, Alpha Centauri A and Alpha Centauri B, are remarkably similar to our Sun. Alpha Centauri A is a G-type star, comparable in size and temperature to the Sun, while Alpha Centauri B is a slightly smaller, cooler K-type star. The 2 revolve around each other in a long, graceful orbit, like a pair of lights intertwined against the deep backdrop of the sky. Together, A and B form a radiant center, where their blended light glows with a warm, golden hue. Much farther out lies Proxima Centauri, the system's 3rd star. Proxima is a red dwarf, tiny and faint compared to A and B. Yet it is Proxima that holds the title of being the closest star to Earth, only about 4.24 light-years away. Its nature is quite different from the other 2. Proxima frequently unleashes powerful flares, causing its brightness to fluctuate. Its surface is far less stable than the Sun's, and for that reason, it has become an important subject for astronomers seeking to understand turbulent stellar environments. What makes Proxima Centauri even more captivating is the presence of at least one planet orbiting it, Proxima b. Discovered in 2016, this planet lies within the region thought capable of supporting liquid water if the surface conditions allow it. Proxima b is roughly Earth-sized, and although its host star bathes it in radiation far stronger than what Earth receives from the Sun, its existence still ignites a quiet hope that just beyond the edges of our solar system, there may be worlds carrying the secrets of life. In the endless flow of the galaxy, Proxima b resembles a tiny gem hidden within the deep red glow of its dwarf star. If one were to imagine standing on a hypothetical planet orbiting Alpha Centauri A or B, the night sky would look profoundly different. Earth and the Sun would appear only as a faint, tiny speck, far dimmer than the way we see Alpha Centauri from Earth. From that vantage point, the Sun becomes an anonymous star among thousands scattered across the Centauri sky. Though the Sun is the center of everything familiar to us, in the vast context of the galaxy, it is merely one quiet point of light among countless others shimmering in the distance. Drifting near this star system in imagination, one could see the blended glow of its three suns forming a strangely comforting scene. Alpha Centauri A and B cast a soft golden light, while distant Proxima adds a faint reddish hue. Together, the three create a portrait that feels both familiar and foreign, like a reimagined version of our solar system, painted with different colors. In the stillness of space, every ray of light from these stars tells a story about the diversity of the universe and the many ways star systems can take shape. Alpha Centauri A and B orbit each other along a large elliptical path, completing one cycle in about 79 years. At their closest, they are around 11 AU apart, roughly the distance from the Sun to Saturn. At their farthest, they drift more than 35 AU apart, even wider than the Sun's distance to Neptune. This slow and steady motion makes the Alpha Centauri binary a remarkably stable system, a place where planets, if they exist, could enjoy long-lasting, steady environments. Simulations suggest that Earth-like planets in the habitable zones of Alpha Centauri A or B are entirely plausible, though none have yet been detected. Proxima Centauri, though smaller and dimmer, tells another kind of story. Its energetic flares can sometimes be so intense that they might dramatically affect the surface of Proxima b. Yet no one knows for certain just how harsh conditions truly are on that distant world. A thick atmosphere might shield its surface, or warm pockets of water might exist beneath layers of rock. Such possibilities make Proxima b one of the most intriguing targets for future missions. Places where generations of star probes might one day search for signs of life. Viewed from afar, Alpha Centauri appears as a single point of light to the naked eye. But up close, its layered structure reveals itself, showing the rich diversity of stellar systems scattered throughout the galaxy. Every star system has its own story, its own history, its own density of stars, and its own unique potential for harboring planets. Alpha Centauri is only our nearest neighbor, yet even it displays the immense variety that fills the universe. Standing at an imagined vantage point near this system, looking back toward the Sun, one might feel just how delicate the solar system is when placed within the grand sweep of the Milky Way. From here, the Sun shines only slightly brighter than any ordinary star, much like how Alpha Centauri appears from Earth. This perspective brings a quiet realization that every star system, large or small, is a piece of a greater cosmic mosaic, and each piece has its role in shaping the galaxy. As one prepares to drift away from Alpha Centauri in this imagined journey, the warm glow of its three stars slowly recedes, becoming a soft cluster of light in the dark. Ahead lies the broader stretch of space within the Orion Arm of the Milky Way, where countless other systems await their names. And from that moment onward, the journey continues into deeper regions of the galaxy, where the next neighbors wait in the quiet stillness of the universe. From the gentle warm light of the three suns in the Alpha Centauri system, the view slowly widens again, as if drifting away from a tiny oasis tucked within the vast ocean of the galaxy. And as that light recedes into the distance, the surrounding space reveals countless new points of brightness, signals that a larger region awaits exploration, the Sun's local neighborhood. The local neighborhood is what we call the region containing the stars closest to us, spanning a radius of a few dozen light-years. To the naked eye, the night sky may look like nothing more than a dark canvas scattered with small dots of light. But on a galactic scale, this region resembles a small neighborhood inside an enormous city. Each star is a home, each planet a mysterious room, and the space between them is made of streets so vast that even light needs many years to cross them. One of the most striking stars in this neighborhood is Sirius, also known as the Dog Star. Sirius is about 8.6 light-years from Earth and shines brighter than any other star in the night sky. Its brilliance comes not only from its closeness, but also from its nature. It is a hot, luminous star, far brighter than our Sun. In reality, Sirius is a binary system made of Sirius A, a white-blue primary star, and Sirius B, a tiny white dwarf with nearly the mass of the Sun. Seen from within this local region, Sirius radiates with a clear, crystalline glow, like a quietly burning gem in the endless dark. A bit farther away lies Epsilon Eridani, a younger star than the Sun, only about 10.5 light-years distant. Epsilon Eridani is one of the most intriguing targets in the search for extraterrestrial life, because it has at least one confirmed planet and possibly more waiting to be discovered. Its atmosphere, temperature, and youthful age make this star system one of the most appealing neighbors for researchers hoping to find signs of life. Tau Ceti is another star sharing this local space, located around 12 light-years from Earth. It is somewhat similar to the Sun, but older, more stable, and glowing with a gentle yellow light. Tau Ceti also hosts its own planetary system, with several planets lying close to the region where liquid water might exist. Though no clear evidence of life has been found, the possibility of oceans, deserts, or unique atmospheres has made Tau Ceti a consistently alluring candidate for deeper study. In a broader view, the local neighborhood is not densely packed with stars like the Galactic Center. Instead, its stars are scattered thinly, each separated by many light-years. But in the scale of the universe, where stars can lie hundreds or thousands of light-years apart, this region is considered crowded. The distances between Sirius, Epsilon Eridani, Tau Ceti, or Alpha Centauri are short enough that they truly function as the Sun's cosmic neighbors. When picturing these stars, one might imagine them as fireflies suspended in deep space. Their light is not strong, enough to erase the darkness around them, yet it is soft enough to mark each star as its own quiet presence. Every glimmer carries a story: its age, its mass, its planets, and its long history of formation. Traveling through the local neighborhood feels like drifting through a vast garden of small lanterns, each guarding a secret of its own. One fascinating feature of this region is what astronomers call the local bubble. This is an area of unusually thin interstellar gas and dust, stretching hundreds of light years and encompassing the Sun along with many of its neighbors. It is believed to have been carved out by ancient supernova explosions millions of years ago. When a massive star dies in a violent blast, the shock wave can sweep away nearby gas and dust, leaving behind an empty cavity that outlives multiple generations of stars. The local bubble explains why the interstellar environment around our solar system feels so clear and sparse. Imagining a journey through this region, space seems more open, easier to breathe, and less obscured by thick dust clouds. This clarity allows nearby stars to appear brighter, closer, and more distinct. For this reason, the local neighborhood is one of the ideal regions for observing subtle changes in the galactic environment. Though each star here has its own planets, temperatures, and history, they share one profound trait. Along with the Sun, they are all traveling together around the center of the Milky Way. Their paths are not straight lines, but vast, gentle arcs, stretching tens of thousands of light years, circling the dense, ancient heart of the galaxy. As they move together, they resemble travelers sharing the same cosmic road, each carrying its own planetary system, yet all bound by a shared journey through the stars. Seen from afar, the Sun and its neighboring stars drift beside one another along a small branch of the Milky Way's spiral structure, known as the Orion Arm. Though it is not as large as the galaxy's major arms, it is wide enough to hold thousands of stars, dozens of star clusters, and many young nebulae in the process of forming. This is the region the solar system calls home, and the source of every familiar pattern in our night sky. As the imagination drifts beyond the local neighborhood, it becomes clear that every star, bright or faint, contributes to a larger picture. They are peaceful markers on the path across the galaxy, reminders that even in the vastness of space, there exist small cosmic neighborhoods where star systems live quietly beside one another like familiar neighbors. And from this gentle point of connection, the journey continues deeper into the structure of the Orion Arm, where luminous nebulae and brilliant star clusters are waiting to be discovered in the stillness of the universe. From the scattered neighboring stars of the local stellar region, the view slowly expands, revealing that all of them are drifting together within a far greater current. And as perception pulls back even farther, the broader structure they belong to begins to materialize. Like a small, curving arm of the entire galaxy, the Orion Arm, the quiet home of the solar system within the Milky Way. If one could look at the galaxy from the outside, as though standing at an impossible height and observing the Milky Way from above, its spiral symmetry would unfold with breathtaking clarity. At the center lies a glowing bar of light, densely packed with countless ancient stars. From each end of this bright bar, two great spiral arms unfurl like ribbons of starlight in the darkness. Perseus on one side, Sagittarius on the other. Between these grand arms, modest yet deeply special, lies a smaller branch, the Orion Arm. It is here that the solar system resides, quietly circling the galactic center within this not too crowded yet wonderfully vibrant spiral lane. Though the Orion Arm isn't as wide as the primary arms, it contains many of the sky's most iconic stars and nebulae, objects humanity has marveled at for centuries. Many of the familiar scenes of the night sky, in fact, belong to this Orion region. One of the brightest examples is the Orion Nebula, located about 1,300 light-years from Earth. It is one of the nearest stellar nurseries, a place where young stars are forming within colossal clouds of hydrogen gas and cosmic dust. Within its depths, towering columns of gas and dust stretch upward like pillars holding up the light, often called pillars of creation. They are not still, but slowly shifting over millions of years, reminding us that the universe is always alive, always changing, even in places that appear utterly serene. The Orion Nebula is not only beautiful, but also one of nature's great laboratories, helping humanity understand how stars are born. Inside it, regions of gas collapse under gravity, heating up and glowing as nuclear fusion begins, the first spark of a new star. This is why the Orion Nebula shines like a pink-violet crystal cloud against the dark backdrop of space. From Earth, it appears as a faint patch within the constellation Orion the Hunter, but through a telescope, its beauty unfolds like a luminous symphony. Near the Orion Nebula lies the Pleiades star cluster, the Seven Sisters. It is one of the most celebrated star clusters in the sky, appearing in the cultural stories of civilizations across the world. The Pleiades are composed of bright, youthful blue-white stars veiled in a thin mist of dusty gas, like a delicate silken scarf. Only about 440 light-years from Earth, much closer than the Orion Nebula, They appear sharp and vivid in the night sky. They are a symbol of togetherness. They're stars born from the same cloud of gas and still traveling through space as a family. The constellation Orion itself belongs to this region. The three aligned stars forming Orion's belt are among the most recognizable patterns in the sky. For thousands of years, civilizations in both the East and the West have watched these stars and woven stories around them. Within this constellation lies Betelgeuse, a massive red supergiant nearing the end of its life. Betelgeuse glows a deep reddish hue, hundreds of times larger than the Sun, and one day will end its life in a spectacular supernova. If that explosion occurs within the next several 100,000 years, its light will outshine the full moon for a brief, brilliant moment in Earth's sky. The Orion Arm also holds numerous dark nebulae, star clusters, and young stellar systems that humanity has yet to fully understand. Together, they form a diverse region where generations of stars are born, age, and eventually fade away. Life on Earth, and perhaps on worlds not yet discovered, owes its existence to the cycles of star formation in regions like these. In many ways, the Orion Arm serves as a cradle of potential life for this part of the galaxy. Placing the solar system within the Orion Arm also reveals that we live on the outskirts of the Milky Way. From this position, the distance to the galactic center is roughly 26,000 light-years. This isn't the most crowded region of the galaxy, nor the most empty. It's something like the quiet edge of a vast city, where the density of stars is just right to offer the stability life needs to flourish. And because we reside in this outer zone, the solar system is shielded from many of the intense effects found near the galactic core, where star density is high, radiation is stronger, and supernova explosions occur more frequently. The Sun and the stars of the Orion Arm are not standing still. All of them are moving together around the galactic center, completing one orbit in about 230 million years. This means that since the age of dinosaurs, the solar system has traveled less than a quarter of the way around the galaxy. During this long journey, neighboring stars slowly shift, nebulae dissipate or gather anew, and even the Orion Arm itself drifts gently within the larger spiral pattern. Looking at the entire Orion Arm, one can sense that it is more than just the solar system's address. It is a region filled with the universe's vibrant life cycle. It is the backdrop of the most familiar sights in the night sky, the birthplace of myths, and the foundation of scientific discovery. Within it, humanity first realized that the galaxy is not a still image, but a continuous flow of creation and transformation. As the imagination drifts away from the Orion Arm, the view begins to stretch toward the denser luminosity of the galactic interior. More distant star clusters, glowing dust clouds, and energetic regions await ahead. From the peaceful home of Orion, the journey prepares to move deeper into the Milky Way's brighter and more complex zones, where the galaxy's heart glows quietly from within the darkness of the cosmos. From the peaceful Orion Arm with its familiar star clusters, the view gradually widens, revealing that ahead lies not an empty stretch of darkness, but vast glowing clouds spreading out like soft streams of color against the night. And as the journey begins to drift away from the solar system's home toward the deeper regions of the galaxy, these magnificent star clouds and luminous nebulae appear like gateways, opening into a brighter, more mysterious, and more vibrant realm of the Milky Way. Along the path toward the galactic center, the character of the galaxy begins to change. The sparse star fields of the Orion Arm give way to broad, softly glowing expanses. These are nebulae, immense clouds made of hydrogen, helium, and cosmic dust, where light spreads in sweeping streaks, like fog illuminated by a hidden energy source. Some nebulae shine brightly thanks to newly formed stars within them. Some appear as dark silhouettes, visible only because they block the starlight behind them. And others are ancient remnants carrying the scars of long-ago supernovae. Approaching one of the most famous nebulae, the Eagle Nebula, the scene feels like stepping into a cosmic painting made of light and dust. Located about 7,000 light-years from Earth, this nebula is home to the iconic Pillars of Creation, towering structures rising from misty gas clouds like soft stone columns carved by time. These pillars, larger than the entire solar system, are sculpted by intense radiation from nearby young stars that blow away the outer layers of dust, leaving behind denser pockets of gas. Inside these pockets, hydrogen slowly gathers under gravity, preparing for the birth of new stars, future suns of the galaxy. Deeper inside the Eagle Nebula, white-blue light from young stars pierces through drifting dust, forming gentle halos that ripple outward. Each beam of light carries the story of star formation, cold molecular gas slowly clumping over millions of years, heating under compression, and eventually igniting in a brilliant burst of nuclear fusion. From this viewpoint, the universe no longer feels silent. It becomes a vast creative engine, always at work, operating on timescales both powerful and patient. Leaving the Eagle Nebula behind, the journey leads toward another breathtaking sight, the Carina Nebula. One of the largest and brightest nebulae in the Milky Way, it lies about 8,500 light-years from Earth. Within it burns Eta Carinae, one of the most volatile and radiant stars ever observed. Eta Carinae is hundreds of times more massive than the Sun and millions of times brighter. Unlike ordinary stars, it is wildly unstable. At one point in history, it brightened so dramatically that it became one of the brightest stars in the sky, only to dim again over time. This extraordinary star is blowing off its own outer layers, creating enormous, intricate clouds around it. From afar, the Carina Nebula looks like a mosaic of thousands of bright and shadowed fragments, each shaped by jets of hot gas or drifting cold dust being hurled outward in different directions. This chaos becomes a kind of cosmic artistry, where light and shadow blend into a surreal, abstract painting crafted by the universe itself. From the nebulae giving birth to stars, the journey shifts toward nebulae of endings, remnants of stars that finished their lives in explosive supernova blasts. The Crab Nebula is among the most famous of these, formed from an explosion observed in the year 1054. Even after more than 900 years, the debris continues to expand through space as a tangle of blue and orange filaments of hot gas. At its center lies a rapidly spinning neutron star, the compressed core of the original star, rotating dozens of times per second and sending out pulses of light across many wavelengths. The Crab Nebula reminds us that the death of a star is not a final end, but the beginning of something new. Heavy elements such as iron, gold, silver, and many of the ingredients essential for life are forged in supernova explosions. They are cast into space, blending with surrounding gas clouds, eventually becoming part of future planets, and even the bodies of living beings. This cycle, born from nebulae, living for millions or billions of years, then returning to the nebulae again, is the rhythmic breath of the galaxy itself. Drifting through these luminous regions feels like wandering inside a surreal painting. Shades of pink, blue, violet, white, and gold merge and soften, shifting with the varying densities of gas and dust. There are no sharp lines or familiar shapes, only broad strokes of light dissolving gently into one another in ways no artist could fully replicate. Every nebula is a living canvas, always changing, even though its evolution unfolds too slowly for the human mind to perceive. These star clouds are not only beautiful, they are records of time. Some nebulae date back to the galaxy's youth, while others are mere hundreds of thousands of years old. Each tells a story of the star that created it, its pressure, its heat, its radiation, and the silence that followed. And though every nebula has its own tale, all are pieces of the great mural painted by the galaxy over billions of years. As the journey continues toward the Milky Way's center, the density of stars increases. The light grows heavier and richer, and the scenery becomes more radiant than the peaceful expanses of the Orion Arm. The brilliant nebulae just encountered feel like the opening doors, leading into regions overflowing with stars, places where the combined glow of millions of suns forms sweeping bands of soft gold. And from this moment onward, the journey prepares to enter a new chapter, one where the ancient heart of the galaxy waits, holding its oldest secrets in the quiet depths of the cosmos. From the soft, multicolored nebulae that glow like night fog lit from within, awareness drifts toward regions where the density of stars grows thicker. And among those overlapping layers of light, a gentle yet immense red glow begins to emerge. Like the galaxy itself is quietly calling us toward a remarkable figure in this journey: the supergiant star UY Scuti. UY Scuti is known as one of the largest stars humanity has ever measured. It rests near the central region of the Milky Way, about 5,900 light-years from Earth by some estimates, or perhaps around 9,500 light-years, according to other studies. No distance is truly absolute, as the measurement depends on the models and methods used. But whether it is 5,900 or 9,500 light-years away, one fact remains unchanged. UY Scuti is one of the most colossal stars ever discovered. Its immense scale becomes unmistakably clear when compared with the Sun. UY Scuti has a radius roughly 1,700 times larger. If placed at the center of our solar system, its surface would reach out to somewhere between the orbits of Jupiter and Saturn. The familiar planets, Mercury, Venus, Earth, Mars, and even Jupiter, would disappear entirely inside its vast gaseous layers. In this comparison, our Sun shrinks into something unimaginably tiny, like a grain of dust beside a gigantic sphere. Seen from Earth, though, UY Scuti is far from dazzling. With an apparent magnitude of around 9 to 10, it is too dim for the naked eye. Only through a small telescope can one glimpse its faint orange-red glow. The reason lies in the star's great distance and the thick clouds of dust that lie between it and Earth. Yet its faintness in the sky cannot disguise its colossal nature, nor diminish its significance in helping us understand the final stages of massive stars' lives. Imagining standing near UY Scuti on some hypothetical orbiting world, the sky would be nothing like the night we know on Earth. A warm, subdued orange-red light would wash across the heavens, and the surrounding star field would be far denser, for regions near the galactic center hold far more stars than the outskirts. The sky would not be a dark backdrop sprinkled with a few bright points, but a woven tapestry of countless visible stars, crowding the view in every direction. UY Scuti is a red supergiant, a star nearing the end of its life cycle. Enormous stars like this begin their lives as brilliant blue-white giants, burning fiercely and consuming their fuel quickly. Once the hydrogen in their core dwindles, they expand, cool at the surface, and shift into reddish hues, becoming red supergiants like UY Scuti. This stage marks a period of instability, as the star's core continually adjusts to maintain equilibrium, while its outer layers swell and contract in slow, rhythmic cycles. As a red supergiant, UY Scuti is living through a brief phase compared with the lifespan of an average star. It has already consumed most of its core fuel and is approaching the moment when it will no longer be able to sustain stable nuclear reactions. When that time comes, the core will collapse under its own gravity, triggering a supernova, an explosion bright enough to outshine much of the galaxy, even if only for a fleeting moment. The blast will scatter heavy elements into space, contributing to the raw material from which new nebulae and new generations of stars will form. But in the moment of this story, UY Scuti remains steady, emitting its soft, orange-red glow. Its light is neither urgent nor overpowering. It feels more like a faint lantern shining through the dusty layers of the galaxy, a glow that does not demand attention, but rather offers a quiet reminder that the universe holds objects so vast they defy familiar scales. Gazing at UY Scuti brings a sense of wonder at the diversity of stars within the Milky Way. Some stars are tiny and fading like dying embers. Some are fierce and white-hot, blazing like cosmic torches. Some are steady and calm like the sun, and others swell into immense globes of gas, dwarfing entire planetary systems, stars like UY Scuti. Each type of star is a different chapter in the galaxy's long, billion-year narrative, each with its own role in the cosmic cycle of birth and death. What makes UY Scuti remarkable is not only its size but also its place in stellar evolution. It serves as a kind of final furnace, where its outer layers are undergoing slow, powerful changes. Within a few 100,000 years, or perhaps less, the star will reach its ultimate threshold and explode as a supernova. When that happens, its light will blaze millions of times brighter than it shines today, visible even from Earth despite its great distance. But for now, UY Scuti is quiet, calmer than the blazing finale that awaits it. Its orange-red glow drifts through cosmic dust and blends with the dense background light near the galactic center. This serenity makes the star feel strangely close, like a gentle giant standing among a crowded field of glittering suns. As the journey drifts away from UY Scuti, its dim red light slowly recedes, yet the impression of its enormity lingers. The universe is not only vast, it is filled with objects that stretch the human imagination to its limits. And from this stop along the way, the journey continues toward the heart of the Milky Way, into the region where stars are packed most tightly, where light merges into a single shimmering glow, and where the galaxy's hidden engine pulses quietly in the depths of space. Under the fading red glow of UY Scuti retreating behind, the space ahead grows denser, as if every step forward draws awareness deeper into the heart of the galaxy. And as the giant's light dissolves into the vast background of stars, the rising radiance signals that the journey is nearing the center of the Milky Way, a place where light and shadow blend into an ancient, intricate structure unlike anything encountered before. The galactic center does not appear all at once. Instead, it spreads gradually into view like a sea of stars growing ever denser. The farther one travels from the outskirts, the more the star density increases, making the surrounding space glow in ways difficult to describe. The stars no longer stand apart like scattered points on a dark canvas. They press together so closely that their light merges into soft, continuous streams. The imagined sky becomes washed in pale golden orange, like a luminous mist, wrapping the journey in a gentle, profound radiance. Closer to the center lies the region known as the central bulge, a swollen core of the galaxy filled with millions of ancient stars. These stars are billions of years old, having lived through most of their evolutionary arc. They no longer shine with the youthful blue-white of newborn stars in nebulae, but instead glow with warm hues of yellow, orange, and deep red, colored by time itself. Each star resembles a quiet ember, glowing patiently for tens of billions of years, and when countless such embers crowd together, their combined light becomes a steady, warm, unbroken glow. This central region hosts many metal-poor stars, stars formed when the universe was still young and heavy elements were scarce. This gives the region its distinct character. Its stars radiate a stable, mellow light, rather than the sharp brilliance of young stellar groups. Many are Cepheid variables, stars that change brightness in predictable cycles, essential tools for measuring distances across the galaxy. Others are ancient red giants nearing the last chapters of their lives. Together, they create a golden sea of stars, breathing slowly in rhythm with the age of the cosmos. As the journey moves deeper, the structure of the center becomes clearer. The Milky Way does not contain only a central bulge, but also a bar, a thick, elongated band of stars running across the core. This bar, stretching thousands of light years, is home to extremely dense stellar populations. From its two ends, the galaxy's major spiral arms unfurl like colossal ribbons. This barred structure explains much about the motion of stars and the distribution of matter, but within this imagined scene, it appears simply as a thicker stripe of brilliance laid across the center of the star-filled sea. Within these interwoven layers of light, a quiet energy pulses outward. There is no chaos here like that of supernova explosions, nor the dreamy shimmer of bright nebulae. Instead, the center holds a steady vitality, like the heartbeat of an ancient being, its light produced by millions of nuclear furnaces burning silently inside old stars. It feels as though the galactic center is not just a place, but a vault of cosmic memory. And then, amid the dense sea of stars, something unusual begins to emerge. Within the overwhelming brightness, there appears a point of darkness, a region that emits no light, yet draws attention more powerfully than any star around it. This darkness is not an empty void, but a doorway into the deepest layer of the galaxy. It is the dwelling place of an object humanity has studied for decades and still cannot entirely decipher: the supermassive black hole Sagittarius A. Sagittarius A sits precisely at the Milky Way's center, acting like an invisible nucleus whose gravity shapes the motion of the entire galaxy. Though it cannot be observed directly, its presence is unmistakably revealed by the stars around it. These stars race at incredible speeds, following tight orbits around a dark point, a point that emits no light, yet contains a mass about 4 million times that of the Sun. Their motion is the signature of a powerful, unseen entity, a supermassive black hole. As the journey approaches this region, the atmosphere subtly changes. It is not fear that fills the scene, but a sense of reverence before a vast mystery. Sagittarius A does not devour everything around it violently like in science fiction tales. Most of the time, it remains quiet. Only occasionally, when a cloud of gas drifts too close, does the region erupt briefly in strong X-ray flashes before falling back into its familiar silence. The black hole behaves like a sleeping giant, resting in darkness, rarely stirring. Against the steady glow of the central stars, this dark point becomes even more striking. It resembles a low, resonant note in the golden-orange symphony of light, a note that deepens the story of the galaxy. The existence of Sagittarius A reminds us that even in a universe filled with light, there are places where light cannot escape. And within those places lie the keys to understanding how galaxies form and evolve. The center of the Milky Way is where light and shadow coexist in a strange equilibrium. Light emerges from ancient stars. Darkness emerges from the supermassive black hole. Together, they create a structure that is both complex and harmonious, the true heart of the galaxy. Standing within this imagined scene, one can feel the immensity of time, the endurance of cosmic processes, and the quiet precision with which the universe arranges its most colossal forms. As the gaze settles upon that mysterious point of darkness, a feeling both thrilling and serene spreads through awareness. The journey has brought us close to the very heart of the Milky Way, a place where the story of the galaxy's origins, motions, and fate is written in the language of light and gravity. And from here, the path leads into the most mysterious chapter yet, where Sagittarius A awaits deeper exploration, like the next page of an unfolding astronomical tale written in the perfect stillness of the cosmos, under the dense golden-orange glow of the galactic center, where millions of stars press together like a silent sea of fire. There lies a particular patch of darkness that draws the eye more strongly than any point of light. And as the gaze adjusts to the overwhelming brightness, a strange quiet radiating from the core becomes unmistakable, as if the galaxy itself were softly whispering a secret it has guarded for billions of years. The supermassive black hole Sagittarius A. Sagittarius A, often abbreviated as SGR A, is one of the most mysterious and significant entities in the Milky Way. What humanity knows about it does not come from direct observation, for no light can escape a black hole, but from the powerful, unusual motions of the stars near the center. This black hole holds a mass roughly 4 million times that of the Sun, and lies about 26 to 27,000 light-years from Earth. Far enough to keep us perfectly safe, yet close enough for observatories to track the strange orbits of the stars caught in its immense gravitational pull. One of the strongest pieces of evidence for Sagittarius A comes from the star S2, one of the fastest-moving stars orbiting the black hole. S2 travels around SGR A in a tight, elongated ellipse, completing a full orbit in just about 16 years. At its closest approach, it hurtles through space at nearly 7,600 kilometers per second, an astonishing speed far beyond anything found in our solar system. The way S2 accelerates and bends its path reveals the presence of a massive, invisible object holding it in orbit. Nothing other than a supermassive black hole could produce such a motion. Imagine witnessing this scene from near the galactic center, S2 and many other stars circling a perfectly black point, a region from which no light escapes. The surrounding space is neither chaotic nor violent, but vast and profoundly quiet. If UY Scuti glowed gently like a dim red lantern from afar, then Sagittarius A is even quieter, its essence defined not by what it emits, but by the complete absence of light. Its presence is known only through what it compels nearby objects to do: orbit, accelerate, bend, and sometimes vanish forever once they cross the event horizon. Near the black hole, even though it emits no light itself, a fragile glow can still be found. This is the accretion disk, a swirl of superheated gas spinning rapidly around the black hole. As matter is pulled inward, it heats up and emits bright radiation, sometimes even powerful X-rays. But most of the time, Sagittarius A does not consume enough material to flare dramatically, so it remains mostly quiet, like a giant creature sleeping deeply, moving only on rare occasions. This calm gives the galactic center a kind of indescribable mystery, brilliant with ancient stars, yet anchored by a heart of pure darkness. In 2022, humanity obtained the first direct image of Sagittarius A's shadow. Captured by the Event Horizon Telescope, the image revealed a distorted ring of light surrounding a dark circle, the black hole's shadow. Though grainy and noisy, the image marked a historic milestone. It confirmed that the models humanity built for black holes were not mere theory, but descriptions of something truly existing at the galaxy's core. That dark region, though tiny compared to the Milky Way, its event horizon spanning only about 23.5 million kilometers, roughly 60 times the Earth-Moon distance, exerts an influence that extends across the entire galaxy. Sagittarius A is the dynamical center of the Milky Way. Every star in the galaxy, including the Sun, moves around it, not because the black hole pulls everything in, but because the galaxy's combined mass, including hundreds of billions of stars and vast amounts of dark matter, creates a shared gravitational field. Yet SGR-AM remains the largest single mass at the center, acting as the nucleus that helps maintain the galaxy's structure over billions of years. Looking at that dark point conveys that the universe's beauty does not come only from what shines, but also from what light cannot escape. A black hole is not an instrument of pure destruction, as many imagine. It is part of a larger cycle, a place where old matter is rearranged and in distant futures may become part of entirely new cosmic structures. Sagittarius A, in its own quiet way, is a machine that helps the galaxy function, silent, patient, and without any need for spectacle. Despite its fearsome reputation, Sagittarius A poses no danger to Earth. Tens of thousands of light-years lie between us, far too distant for its gravity to affect the solar system in any measurable way. Everything we experience, Earth's orbit, seasons, tides, is governed solely by the Sun. Sagittarius A is simply a remote coordinate on the galactic map, a point that the solar system will take hundreds of millions of years to trace even a small portion of its orbit around. When the story of Sagittarius A settles, it feels as though we have brushed against a deep layer of the universe, a place without light or sound, yet filled with information about how the galaxy operates. From here, the imagined journey begins to drift outward once more, leaving the dense, glowing center behind and returning toward the broader expanse of space. Ahead lies a sweeping perspective where the entire Milky Way, with its bar, spiral arms, outer halo, and mysterious heart, can be seen as a single structure, turning slowly in the darkness of the cosmos. And as we prepare to leave the center and view the galaxy from afar, the next part of the journey opens like a gentle doorway, carrying awareness away from the shadowy core and toward the grand, full portrait, where light and darkness together tell the story of the galactic home we all belong to. From the dark depths where Sagittarius A resides, where light is bent and swallowed, space gradually brightens again as distance grows, like a gentle breath expanding the field of vision. And as that depth recedes behind, the sensation of having just stepped out of a cosmic secret allows the Milky Way to appear more fully, more widely, as though awareness were being lifted up to observe our entire galactic home from the outside. As the imagined starship drifts away from the dense stellar core of the Milky Way, the scene behind softens into a warm sphere of light. A little farther still, the galaxy no longer surrounds the observer. It becomes an independent object, hanging quietly in the deep darkness of space. The Milky Way appears whole at last, like a blossom of light turning slowly in the endless night. This is the first moment in the journey where the listener is invited to picture the galaxy clearly, as if standing outside it, viewing it in perfect stillness. The Milky Way is a barred spiral galaxy, one of the common structures in the universe, yet possessing a beauty that defies simple description. It spans about 100,000 light-years, stretching outward like a delicate, flattened disk composed of hundreds of billions of stars. Its major spiral arms curve gracefully around a bright central region, forming a shape that is both balanced and elegant. Seen from afar, each arm resembles a flowing river of starlight, made from countless young stars, glowing nebulae, and radiant star clusters winding toward the rim of the galaxy. The galaxy is not a thin sheet, but has a thickness of roughly 1,000 light-years. Its bright center, the bulge, swells into a golden sphere filled with ancient stars that have lived for billions of years. Cutting through this bulge is the central bar, a long, dense band of stars stretching thousands of light-years. From the two ends of this bar, the major spiral arms, the Perseus Arm and the Centaurus Arm, unfurl into space, forming the Milky Way's iconic shape. Between them lie smaller arms, including the Orion Spur, the quiet little branch where the solar system resides. Focusing on the Orion Spur, the Sun appears as a tiny point among a sparse cloud of stars on the inner edge of the galactic disk. It sits roughly 26,000 light-years from the center, far enough to avoid the intense turbulence of the core, yet close enough to still sense the faint glow of the older stars there. From this vantage point, everything familiar, the solar system, the Earth, even the entirety of human history, shrinks into a speck indistinguishable within the galaxy's vast glow. The solar system does not lie on a major spiral arm, but on the edge of a small, narrow, and unassuming spur. This makes our position extraordinarily modest. From the outside, the Orion Spur is nowhere near as radiant as Perseus or Centaurus. It looks like a thin thread of light drifting quietly between two brighter rivers of stars. Yet, that is the birthplace of the Sun, of Earth, of all life we know. The universe is immense, and life has rooted itself here, on a small branch of a much larger spiral structure. Surrounding the galactic disk is the halo, a region of hot gas stretching hundreds of thousands of light-years above and below the plane. Within this halo lie about 150 ancient globular clusters, each containing tens of thousands to hundreds of thousands of old stars. These clusters move around the galaxy like small satellites. From a distance, they resemble floating droplets of starlight, encircling the Milky Way in a thin, shimmering veil. They are relics from the galaxy's earliest days, carrying the chemical fingerprints of a time when the Milky Way was just beginning to take shape. The hot gas in the halo is more than mere structure. It holds remnants of supernova explosions and streams of ionized material shaped by countless cosmic processes. It does not shine brightly like the spiral arms, but gives off a diffuse glow, like a faint luminous fog that makes the Milky Way appear gently wrapped in a glowing blanket. From this external view, the galaxy no longer feels abstract or overwhelmingly large. It becomes a defined object, structured, shaped, dynamic. A being with a center, with limbs, with patterns and motion, with parts that relate to one another like organs of a living body. For the first time, humanity can imagine the Milky Way not just as a sky full of stars, but as a singular cosmic entity. And with that realization comes a subtle shift in perspective. We are not at the center, not special in cosmic terms. We are a tiny part of something immeasurably larger. But the Milky Way is not alone. In the surrounding darkness, countless other galaxies drift, some larger, some smaller, some approaching, some receding. Together they form what is known as the local group, a vast intergalactic neighborhood where the Milky Way shares its motion with nearby companions. And knowing that our galaxy, already immense and intricate, is just one among hundreds of billions in the universe, gives the story an even deeper resonance. Looking at the Milky Way from the outside, the listener may feel a beautiful balance between humility and grandeur. One galaxy among many, one star among billions, one small planet holding the only known life. Yet that life has developed the awareness to look back at the structure that created it. In the stillness of intergalactic space, the Milky Way's spiral form glimmers as it turns slowly, granting the journey a new layer of meaning. And from this moment onward, the story expands once again, now reaching beyond a single galaxy, toward its intergalactic neighbors, the sister galaxies drifting with the Milky Way across the vast cosmic tapestry. Under the quiet scene where small satellite galaxies circle the Milky Way like soft, gentle lights of a peaceful cosmic neighborhood, attention slowly shifts toward something farther, larger, and far more powerful. And from that outer edge of the local group, a colossal silhouette drifts steadily closer, its presence so majestic that the entire intergalactic landscape seems to unfold with a deeper meaning. The Andromeda Galaxy is our most prominent and imposing neighbor. If the Milky Way is considered a grand spiral system, then Andromeda surpasses it with ease. Spanning roughly 140,000 light-years, significantly wider than the Milky Way's approximate 100,000 light-year diameter, Andromeda is a true giant. It contains as many as 1 trillion stars, nearly 3 times the number found in our own galaxy. That number alone paints the image of a vast ocean of starlight, overflowing with energy and rotating gracefully through the cold dark of space. The distance between the two galaxies is about 2.5 million light-years, a staggering separation by human standards, yet surprisingly modest on the scale of the universe. What feels miraculous is that despite this distance, Andromeda can still be seen from Earth with the naked eye under a dark sky. In the constellation Andromeda, it appears as a faint, elongated blur, larger than the full moon if measured by angular size. The light the listener sees is made of hundreds of billions of stars, each beginning its journey long before the first humans ever walked the Earth. It is a reminder whispered softly across time and space. The night sky we look at each day carries stories far older than humanity itself. Andromeda is not merely a large spiral galaxy. It's a living structure, filled with motion and renewal. Its luminous core glows warmly, while its spiral arms overflow with gas, dust, and countless regions of star formation. Here, clouds of matter gather and collapse under gravity, giving birth to young, blue-white stars. In many ways, Andromeda feels like a reflection of the Milky Way, a bigger, older sibling that still shares the balanced beauty of a barred spiral form. If the listener could look even closer, they would notice that Andromeda, too, has its own system of satellites. Just as the Milky Way has the Magellanic Clouds, Andromeda is orbited by numerous dwarf galaxies. The Triangulum Galaxy, M33, the third largest galaxy in the local group, has a gravitational connection with Andromeda, and the two interact strongly with one another. Countless smaller dwarf companions also surround Andromeda, drifting like tiny pieces in a grand cosmic dance, forming a galactic family with Andromeda at the center. But what truly sets Andromeda apart is its direction of motion. Most galaxies in the universe are receding from one another, due to the expansion of space. Andromeda, however, is among the rare few that are moving toward us. At a speed of about 110 kilometers per second, over 400,000 kilometers per hour, it approaches steadily, though the listener can feel none of that motion directly. This is no cosmic anomaly. It is simply the mutual pull of gravity between the two most massive galaxies in the local group. This leads to an inevitable future. About 4 billion years from now, Andromeda and the Milky Way will collide. Not like solid objects crashing together, but through a slow, majestic interweaving that will last billions of years. From Earth, Andromeda will appear larger and brighter in the sky, expanding into a luminous swirl before the two galaxies finally merge into one radiant display of stars and motion. Eventually, the combined system will settle into a new form, likely a giant elliptical galaxy, born from the union of the two. Before exploring that merger in the next chapter, we pause here, at this moment in time, to appreciate Andromeda as it exists now. From afar, it looks like a delicate spiral of light, with a soft golden core and pale blue-white arms extending far into space. The glow of its stars blends into a smooth, mist-like sheet, bright yet gentle. Its spiral arms resemble flowing currents, carrying gas and dust outward across tens of thousands of light-years. If one could stand on an imaginary planet in another galaxy and look toward Andromeda, it would appear as a vast, spinning disk drifting slowly through the void. It is one of the brightest galaxies visible from such a distance, an astronomical masterpiece visible across millions of years of travel. Andromeda also feels strangely familiar, not because it resembles the Milky Way, but because it is our largest, closest neighbor, destined to share a connected future with us. In the universe's great ocean, two massive galaxies drifting toward each other is not rare, yet it is extraordinary that humanity is able to know, understand, and imagine such a grand cosmic motion. Andromeda stands as a reminder of the universe's profound dynamism. Everything moves, everything evolves. Even structures as enormous as galaxies have lifetimes, histories, and futures. It sparks a quiet understanding that the Milky Way is not an isolated island, but part of a broader network of galaxies journeying together through cosmic time. And as the image of Andromeda settles gently into the mind, the story opens to its next chapter. What will unfold when the two largest galaxies of the local group finally meet? The journey continues forward toward the magnificent slow-motion collision that awaits, a celestial epic written across the distant sky. Beneath the majestic silhouette of Andromeda hanging in the depths of space, the image of that colossal neighbor reveals not only the beauty of a brilliant spiral galaxy, but also a long-kept secret about the shared future of our two galaxies. And from the moment we take in that breathtaking sight, the thought of a destined encounter quietly unfolds, almost as if the spiral arms of both galaxies were reaching for each other invisibly across billions of years. In a distant future, about 4 billion years from now, Earth's night sky will transform in ways no living creature has ever fully imagined. Andromeda, now just a faint smudge high above our heads, will slowly expand with every passing million years. Its light will stretch across more and more of the starry dome, turning Earth's night into something wondrous in a completely unfamiliar way. And as the stars of Andromeda grow brighter, their glow will mingle with the starlight of the Milky Way, creating a double-layered sky where two galaxies share the same cosmic canvas. Then, the collision will begin. But collision, in this sense, bears little resemblance to anything we know on Earth. The stars in each galaxy are spaced so incredibly far apart that almost none will ever strike another. The chance of 2 grains of dust drifting into each other in 2 separate deserts is incomparably higher than the chance of 2 stars colliding. Instead, the galactic encounter will unfold slowly, gracefully, stretched over timescales far beyond anything the human mind was built to measure. The gravity of each galaxy will tug at the other's spiral structure, stretching and bending their arms, twisting them into spectacular cosmic shapes. Waves of gravitational compression will sweep through the gas and dust. As the material thickens, clusters of new stars will ignite, forming brilliant starburst regions. Young, blue-white stars, hot and vivid, will illuminate the cosmic night like silent fireworks. The effect may be gentler if the 2 galaxies have already used up much of their gas, but still bright enough to send shimmering ribbons of light stretching across hundreds of thousands of light years. From Earth, if any living observers still exist, the view would be grander than any dream. Around 4 billion years from now, when Andromeda dominates the sky, its light will overlap with the glow of the Milky Way, creating irregular bands of brilliance, 2 celestial paintings slowly sliding over one another. Then, around 5 to 6 billion years from now, the galaxies will completely intermingle. The Milky Way's bright core and Andromeda's core will draw closer in a tightening spiral, eventually merging into a single central point where gravity rules with an intensity nothing can escape. The supermassive black holes at the hearts of both galaxies will also swirl toward one another in that merging dance. They will move in a strange gravitational waltz through the vast silence, stepping closer with immense, shrinking orbits. When they finally meet, they will fuse into a single, even larger black hole, potentially unleashing a dramatic outburst of energy, whether in X-rays or gravitational waves, an exclamation point marking the unification of 2 galaxies. After roughly 6 to 7 billion years, all the chaos and distortion will settle, giving rise to an entirely new astronomical being. This galaxy may take on an elliptical or spherical shape, no longer displaying the spiral forms of its parents. Astronomers sometimes call it Milkomeda, a blend of Milky Way and Andromeda. It will be bigger, brighter, older, and infused with the intertwined history of both galaxies that came together to create it. There is also a chance that the Triangulum galaxy, M33, the 3rd largest member of the local group, will be drawn into this grand merger. It may be captured and absorbed by Milkomeda, or become a satellite orbiting the newly formed giant. Whatever the outcome, its fate will be rewritten by the immense encounter, stretched, twisted, or even dissolved into Milkomeda over tens of billions of years to come. In that far-off future, the solar system is unlikely to remain in its familiar place. As the galaxies unite, the orbits of countless stars will be violently reshuffled. The Sun, aged and nearing the end of its life, may be pushed far outward from its current position, flung to the galaxy's outskirts, or even cast into intergalactic space. Earth, if it still exists at all, will no longer harbor life, for the Sun will have swollen into a red giant billions of years earlier, scorching away every trace of habitability. So whether the solar system remains or is cast out, no living beings will be present to witness the merging galaxies. And yet, none of this carries the tone of tragedy. On the scale of the cosmos, this is simply the natural rhythm of galaxies. They form, grow, meet, merge, and transform across the ages. To the universe, cycles spanning billions of years are merely soft exhalations of a vast living entity. Seen this way, the merger of the Milky Way and Andromeda feels less like a loss, and more like a slow, luminous waltz written in starlight and gravity. The final image is a serene portrait of transformation. Two magnificent spiral galaxies slowly melting into one another, their blue-white arms flowing like currents of water, until they blend into a glowing elliptical form drifting gently through the perfect black of space. A colossal dance across billions of years, marking the cosmic destiny of the Milky Way, grand, romantic, and beyond the reach of any words to fully capture. As the billion-year-long waltz between the Milky Way and Andromeda draws to a close in one final spiraling step, the once chaotic tableau of light, gas, and dust settles again, like the surface of a lake calming after a powerful wind. And in that moment of deep stillness, a new cosmic era begins to unfold, revealing the shape of a young galaxy just born from the fading remnants of its two spiral ancestors. This newborn galaxy is sometimes called Milkomeda, a fusion of Milky Way and Andromeda. Yet whatever name it takes, its nature carries a tone entirely different from the galaxies that once existed. The graceful spiral arms of the Milky Way, the soft symmetry of Andromeda, both are gone. In their place, Milkomeda takes on the form of a massive elliptical galaxy, rounded but faintly luminous, dressed in gentle shades of reddish gold. The unmistakable sign of an aging stellar population, where few new stars are still being born. At Milkomeda's center, its immense core glows brightly, yet less densely than the cores of its parent galaxies. The merger had flung many stars into wide, wandering paths, thinning the star population near the center. Orbits that were once stable and orderly broke apart, giving way to long, chaotic trajectories. Stars that once belonged to the Milky Way or to Andromeda can no longer be separated into distinct families. They blend seamlessly into one intricate web of motion, circling the new galactic heart like golden dust swirling inside a glass sphere. No clear pattern, yet bound by a single shared gravity. This chaos is not a sign of instability, but rather the natural character of a mature elliptical galaxy. The new galaxy does not spin quickly like a spiral, does not form elegant winding arms, but instead exists as a vast cloud of stars, where each star's motion weaves into the next, like a dance without choreography, yet full of quiet internal harmony. Another important outcome of the merger becomes evident. Most of the free gas and dust in the original galaxies has been spent. During the early phases of the encounter, shock waves and compression triggered breathtaking bursts of star formation. But once Milkomeda stabilizes, the remaining gas within its disk has dwindled to a level too low to create stars in large numbers. And so, the new galaxy takes on the temperament of an old system, gently radiant, steady, no longer flashing with the energy of young stars. As the listener looks farther ahead, to hundreds of billions of years after the merger, the story expands into deeper time. Milkomeda will not remain alone, born only from two great galaxies. It will slowly draw in the small satellite galaxies that once formed the local group. Tiny systems like Leo the One, the Fornax dwarf, or the Sagittarius dwarf will drift inward over the ages, eventually being absorbed. One by one, these dwarfs will dissolve into the larger galaxy, adding stars, gas, and dark matter to its quiet reserves, allowing Milkomeda to continue growing in a subtle, almost invisible way. Far deeper into the future, as the universe keeps expanding at an accelerating pace, the distances between major galaxy groups will stretch so greatly that no instruments will be able to detect them. The local group, by then fully merged into a single massive galaxy, will drift through the void with no neighbors left within sight. Other galactic cores across the universe will recede so quickly that their light will never reach Milkomeda. On the cosmic scale, Milkomeda becomes a lone island of light in a darkened ocean, existing in isolation for trillions of years. And in that setting, a philosophical notion arises. Every galaxy has its own life cycle. From its formation within ancient clouds of primordial gas, to its flourishing as a spiral structure, to its final transformation into an aged elliptical form. Each stage is part of a cosmic rhythm far larger than humanity. Compared with such timescales, the entire history of humankind is no more than a breeze gliding across a quiet lake. This realization is not meant to make us feel small, but to inspire humility and peace. We are a small part of a grand symphony of space. As these reflections gently fade, the story guides the listener back to the present, a moment in which our Milky Way is still in the middle of its life. Tonight's sky still carries its soft spiral arms, stretching across the dark like luminous silk. The stars still burn bright, still trace steady paths around the galactic center, and Earth still moves quietly along its gentle orbit around the sun. That distant future, billions of years from now, remains only a long dream, one we can imagine but need not fear. And so, this section lingers as a tender echo before closing the journey across the Milky Way. It reminds the listener that although galaxies evolve, and although the future may stretch beyond imagination, the present moment remains whole in its own way. The Milky Way we see each night is still a breathtaking portrait. And in understanding the life cycle of a galaxy, we learn to appreciate our own small but meaningful existence within the vastness of the universe. As the image of Milkomeda slowly dissolves into the night of imagination, leaving behind a quiet, reddish-gold, elliptical galaxy drifting through an ever-expanding universe, awareness gently begins to return to the present. And from that soft pause, it feels as though a delicate thread stretches all the way from the galaxy's distant future back to this very night, guiding us home to where the journey began. The long voyage across billions of light years and billions of years of history now comes to a warm close beneath Earth's familiar night sky. Overhead, the silver band of the Milky Way still stretches like a slender ribbon of soft light across the deep expanse. But this time, it is no longer an anonymous spectacle, no longer a mystery suspended in darkness. It is an old friend, one that has just shared the story of its life through 17 chapters, and we stand here, understanding it more intimately than ever before. From the starting point under a peaceful starry night, to the moment we left the solar system and sailed past the planets, to the farthest boundary of the Oort cloud, then into the quiet depths between the stars. From nearby neighbors like Alpha Centauri to the stars of our local bubble, from the familiar Orion Arm to ethereal Nebulae and the giant star UY Scuti, from the dense brilliance of the galactic center to the dark mystery around Sagittarius A, then outward beyond the Milky Way to see its full form. From the tiny satellite galaxies to the colossal neighbor Andromeda, and finally to the billion-year dance of their merger. All of those paths now fold into a single moment of stillness, like one long, steady breath. Returning to Earth, the listener can almost feel space shrinking back around them. The night sky, once impossibly vast, becomes an embrace. The Milky Way remains above, yet every star, every dust lane, every swirl of light now carries its own story. The tales just told do not make the listener feel small in a lonely way. They make that smallness beautiful, meaningful, a rightful place within the cosmic tapestry. Our Earth lives inside a grand galaxy, yet that galaxy is only one among hundreds of billions more. This truth does not diminish Earth's value. It makes human life even more remarkable. We are able to look up at the sky and understand that we belong to a tiny corner of a story far greater than ourselves. And in that humility lies a quiet peace, as though we are slipping gently into the rhythm of the universe. When the listener recalls everything they've absorbed, the knowledge drifts through the mind like a breeze. No longer dry numbers, but vivid images. The size of UY Scuti stretching out to the orbit of Saturn. The speed of star S2 as it slings past the central black hole. The elegant spiral silhouette of the Milky Way. The shadow of Sagittarius A captured in 2022. Nebulae such as the Pillars of Creation, and the final portrait of Andromeda in the far future. Each memory glimmers like a tiny mote of stardust settling onto a still lake. No noise, no spectacle, just gentle ripples spreading outward, sinking slowly into awareness like soft, drifting fragments of information, ready to accompany the listener into deep sleep. Under this familiar night sky, the Milky Way's glow feels like an invisible hand resting on the mind, reminding us that although humans are fleeting beings in cosmic history, the feeling of belonging to something larger is absolute and immutable. We are not drifting alone. Earth, the Sun, the Solar System, the Orion Arm, and the Milky Way itself are all traveling together through space, carrying us along in an endless, graceful motion. And so, as the journey closes, the good night that follows is not an ending, but a gentle send-off. Let these images of the cosmos lull the listener into sleep, so the mind may continue its own quiet voyage in dreams. Let the vastness of space remind us that every night's rest is its own small journey, and within that journey, the listener is never alone. Because above all, we are all children of the Milky Way. And tonight, beneath a sky full of stars, we drift together in peace across the boundless ocean of the universe.